Okay, now let's look at the number 18 and we will fill in the blanks. Can you fill in the blanks for the second and third line first by yourself? It should be easy. Okay, all done? All done? Don't forget, we are trying to learn about factors over here. So, can somebody please tell me what should go into the first blank? 2 times what equals to 18? Okay, 2 times 9. Easy, huh? What about the third blank? Sorry, the second blank. 3 times? 3 times 6 equals to 18. Okay, very good. So what about any more numbers? Can we try any more numbers? Because we see over here we have 1, 2, and 3, right? Can we try any other numbers to find the factors of 18? Let's just try, okay? Let's try 4 times what equals to 18? What do you think goes into this blank? How much? 4.5. Okay. Basically, the answer, the number that you put in over here will have a decimal point, right? It won't be a whole number. So that is why 4 is not a factor of 18. Okay. Let's try 5. 5 times what equals to 18? Will I get a whole number? Will I get a whole number? No, I won't. I will get a decimal point. So I don't even want to try 5. What about 6? 6 times what equals to 18? 3, right? 6 times 3. But have we seen this before? We see it over here, right? 3 times 6 equals to 18. 6 times 3 equals to 18. Are they the same thing? They are the same thing. That is why we don't care about all this. And since 6 times 3 is equals to 18, it is the same over here. So we don't even do it anymore. It is a repeat. Don't do extra work, okay? So can you tell me what are the factors of 18? What are the factors? 1, 2, 3, 6, 9. And these are the factors. Please fill in the blank. Alright, so this means that when 18 is divided by each of these factors, I don't care which number you choose over here to divide 18 by, the remainder is 0. Correct? Right or wrong? 18 divided by 9, you get 2, remainder 0. 18 divided by 6, remainder 0. 18 divided by 3, remainder 0. 18 divided by 2, remainder 0. 18 divided by 1, remainder 0. So these are factors. We also say that 18 is divisible by 1, 2, 3, 6, 9, and 18. When we say it is divisible, we mean that there will not be any remainders. Okay, so far? Who is following the class? Please raise your hand. Who thinks you are still understanding what I'm saying? Okay, thank you. Put on your hands. Now, next one, try yourself. I will show you the first few lines. 60 equals to 1 times 60. Maybe I do another one for you. It is equals to 2 times 30. Can you do the rest yourself? Who has finished? Okay, thank you. Put on your hands. Let's give the rest a little bit more time. If you have finished, you can go on and read the rest first. Okay? Who needs some more time to finish it up? Raise your hand. Don't be shy, huh? If you need more time, you must tell me. Otherwise, I move on so quickly, then you cannot follow, then you will be in trouble. Okay? Who needs a bit more time? Right. What is the next line? Can I have everybody tell me the answer? What is it over here? 3 times 20. Next one? 4 times 15. Next? 5 times 12, and finally 6 times 10. Can I actually go on? Let's try, okay? Let's see what else I have. 60 equals to 7 times, what should I put in here? Do I have a whole number? No, don't have. So let's not do this. Equals to 8 times. Can I have a whole number here? Also cannot. Okay. What about 9? Do I have any answer? Don't have. What about 10? 10 times 6. Oh, then it is a repeat, right? So do I continue? No need to continue already because you'll be wasting your effort. However, if you want to continue, what else will we see? We will see 12 times 5, which is over here. Then we will continue, we have 15 times 4. Can you see that all these are repeats? So no need to do them already, so on and so forth. Okay? Once we see that the number is repeated, we stop. Then we don't want to do this anymore. 10? Okay, so what are the factors of 60? Can you list down the factors of 60? 1, 2, 3, 4, 5, 6, 10. 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. These are the factors of 60. Okay? Oh, by the way, has anybody in your primary school said to you that, oh, you need to improve on your handwriting? Have? Okay, so probably some of you were told that you need to improve on your handwriting because especially in mathematics, we write many things, right? What if your handwriting is so bad that I can't read it, or I think you're writing something else, but actually you know how to do the question? Isn't it a very bad deal for you? If you know how to do it, but because your handwriting, Mr. Wong doesn't understand, then you cannot get a full mark. So you need to be careful with how you write. Everything must be neat and clear. Okay? Now, list all the factors of 56. Can we start doing this quickly? If you need to, you can do it this way, or you can do it mentally with just your calculator. It is fine. So there's a small space over here. Let's write down the answer for A. The factors of 56 are, the first factor is definitely 1, comma. Continue, try yourself. I'll give you 3 minutes to do this. You can use your calculator if you want to. Who needs more time with part A? Okay, let me show you the answers for part A and how I will do it. So I'll need some space. So 56 is equals to 1 times 56, 2 times 28. Is it? Okay, you can't divide it by 3, right? Can I divide it by 3? I cannot. So next one will be 4 times 14. Can I divide by 5? What about 6? 7 equals to 7 times 8, right? What is next? What about 8? 8 times 7. Can we see that it is repeating again? So do I need to do this line? No need, right? Okay, I can stop here already. So the factors of 56 are 1, 2, 4, 7, 8, 14, 28, and 56. Okay, do you have all these? If you have them, very good. If you don't have it, use your green pen and include what you missed out on. So by doing it this way, I will not miss out on any factors. Now some of you, as I walked around, I saw that some of you were just writing down numbers without much calculation. You anyhow choose some numbers to test. Then that may result in you missing out on some factors. So in order not to miss out anything, we do it step by step from the smallest number all the way until it repeats itself. Okay? So part B, we can do the same thing. The factors of 84 are 1, 2, 3, 4, 7, 12, 21, 28, 42, and 84. These are the factors of 84. You can just copy this down. You can go back home and check your calculator. You can go back home and check whether these are really the factors by dividing and checking that there are no remainders. Okay? So next part, find all the factors common to 56 and 84. So we have this term over here, common. Common factors, isn't it? Yes? Say again? 6 is a factor. Yes, 6 is also a factor. Thank you. Did I miss out anything else? Any more missing? So you see, your teachers can also make mistakes, and I need you to help me check as well. Okay, 6 is also a factor. 14. Okay, so over here, 14 also. Any more? Okay, that should be all, yeah? Now we find the common factors. What are they? Which factors appeared both in 56 and 84? We have 1, so common factors. 1, 2. Any more? 4. Any more? 7. 14. 28. Any more? Is that all? Okay, so these are the common factors. So far easy enough. Sounds like your primary school work, right? Okay, so everybody should be able to do all these things. Then let's go on to exercise 3, true or false question. I just need you to think about this at home. Okay, so this is your homework. Your homework for this one on your notes. Whatever I want you to write inside here, you don't need to attach this one. This one goes onto your foolscap. Okay? This one is for your homework from your textbook goes onto your full scan. Okay? So over here, you just write whether it is true or false. You just do it yourself, can? Let's move on. Multiples. If we learn factors, then we should also know how to do multiples because they are related. When a number is multiplied by a non-zero whole number, we get a multiple of the number. What does this mean? Very easy. Let's try the first question. Write down the first 6 multiples of 5. What are they? What's the first multiple of 5? 5. Then 10, 15, 20, 25, and 30. Easy enough? Okay, so please make sure you have all these in your notes. Oh, is part B a bit more difficult? No, right? It's very easy, right? Okay, let's just do it. 11, 22, 33, 44, 55, and 66. Okay, find the largest multiple of 11, which is less than 50. So what should the answer be? 44. Okay, that's all. Let's go on to exercise 5. Show that 28 is a multiple of 4. How to show? How do we show this? 28 divided by 4 and I will get? So how does that show me it is a multiple of 4? No remainder. Doesn't that sound like you're telling me 4 is a factor of 28? But I'm asking you to show me that 28 is a multiple of 4. Although they are very related, there is a way that we want you to present your answer. Okay? So, I want you to pay close attention to this. Whenever I want you to show that 28 is a multiple of 4, or show that something is a multiple of something else, I want you to write it down this way. 28 equals to, write it down first. 28 equals to 4 times 7, right? Can we write this line easily? So what does this tell me now? This tells me that 28 is a multiple of 4. Understand? So as long as I can write it down this way, and over here I have whole numbers, that means that 28 is going to be a multiple of 4. Okay? So after I write down this line, my next line, my conclusion will be, hence 28 is a multiple of 4. Okay, all those in red. Can you try part B yourself? Do it the same way for part B. Okay, who needs more time for part B? Right, so in part B, 732 equals to 6 times 122. Oh, if I can write it down this way, where 6 and 122 are whole numbers, they are integers, then hence 732 is a multiple of 6. Okay, now part C. Show that 243 is not a multiple of 2. How should we do this? What do you think? Can we do it the same way? What happens if I use the same method? Okay, let's see. 243 is equals to 2 times what? What is that decimal number? How much? Times 121.5. Correct? Oh, okay. This line, nothing wrong with it. Right? Because you take your calculator, 121.5 times 2, you get 243. This line is correct. But what is the problem over here? Yeah, this one, decimal. It's not a whole number. That means that 2 is not a factor of 243. In other words, 243 is not a multiple of 2. Okay, so since 121.5 is not a whole number, or in this case we can call it an integer. It's not an integer. Since it is not an integer, then 243 is not a multiple of 2. Okay? Any questions so far? No questions. Are you sure? Are you sure? No questions? Yes. Excellent. What is an integer? You notice this word over here? Integer. What have I been using previously? Whole numbers, right? I call all these whole numbers. Then suddenly, I introduce this word integer. So, an integer is also a whole number. Okay, integers are examples of integers are 0, 1, 2, 3, 99, 2015, 1 million, so on and so forth. Okay? All these numbers. But why is it that I want to call this an integer and not a whole number? Because I also have negative integers. For example, negative 5, negative 99, negative 100, so on and so forth. Okay? So the term that we want to use when we talk about multiples is integer. Okay? Don't worry about it. For now, you can treat it as whole numbers first. Okay? But the correct word that we want to use will be integers. For now, you can treat it as whole numbers first. Okay? Next, a prime number. Have you heard of a prime number? Have you all learned that? What is a prime number? Okay, something like that. A prime number is a number that can be divided by 1 and itself only. So only has two factors, 1 and itself. Okay? So can you list down the first 5 prime numbers? What is the first prime number? Is 1 a prime number? Is 1 a prime number? No, it is not. Because 1 can be divided by 1 and 1. So this 1 and this 1 over here, they are the same number. There's only one factor. Whereas my prime number says that it must have 2 factors. So 1 is not a prime number. What about 2? 2 equals to 1 times 2. That's all right. So 2 is a prime number. Okay, that is the first one. Nothing else. What about 3? 1 times 3. Any more? Don't have, right? So it's just 1 and 3. What is the next prime number you can think of? Are you sure it's not 4? Can I try? Let me just try 4, okay? 4 equals to 1 times 4. Oh, I see only 2 factors. Yes, there is another option. We have 2 times 2. So over here, 4 has 1, 2, 3 factors. 1, 2, and 4. Therefore, 4 is not a prime number. So I don't want that. Next one will be 5. 1 times 5. Okay? What is the next prime number? 7. Next? 11. Okay, because 8, 9, 10, they are not prime numbers. They have more factors than 1 and itself only. So these are the first 5. How many prime numbers do you think there are in the world? How many prime numbers do you think there are? 10? Or more? More. Many, 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 many more. How many? Infinite. There are infinite numbers or prime numbers, okay? So, besides prime numbers, some over here prime numbers, we have this thing called composite number. Have you heard of this English word composite? Composite means it is made up of more than one thing. Made up of more than one thing. So, a composite number is a whole number greater than 1. And it has more than 2 factors. What is a number that is greater than 1 and has more than 2 factors? Can you give me an example? 4. Yes, we saw it just now, right? 4 equals to 1 times 4, and it is also equals to 2 times 2. So 4 factors of 4 are 1, 2, and 4. So we see that for this number 4, it is greater than 1. It has more than 2 factors. So 4 is a composite number. First composite number will be 4. What is the next number? 6. Next? Okay. Next? 9. Then 10. All these numbers, they have more than 2 factors. They have 3, maybe 4, so on and so forth, okay? Any questions so far? Then, do you now know the difference between prime and composite? Hannah? Okay, explain why 0 and 1, they are not prime, they are not composite numbers. Why? Why is it that I don't have a 0 over here? Why is it that I don't have 1 over here? Can you tell me why? Look at this statement carefully. And this statement, look at it carefully. Some of you saw it already. I won't tell you the answer. You go and read carefully. You will be able to answer why. Why is it that 0 and 1, they are not prime and they are not composite? So over here, homework again. Try and fill this up. Okay? Next lesson, we will go through it. Next one, exercise 6. Determine whether each of them are prime or composite numbers. Can you determine yourself? For example, for part A, prime numbers are, what are the prime numbers over here? Is 15 a prime number? Okay, let me just write out composite also. Okay, let's look at the first number, 15. Is it prime or composite? Why is it composite? It's more than 2 factors. I've got 1, I've got 3, I've got 5, I've got 15. So that is more than 2 factors already. So over here I've got 15. What about 17? What number is it? Prime number? Okay. Can we fill the rest yourself? What about, I gave you the answer already. What about 19? Also prime number. Then 21. Who is Rui Qi? What number is this 21? Prime or composite? Very good. What about 27? Let's have Sheldon. 21. Prime or composite? I can't hear you. Yes, I'm talking about 27. Prime. Why? What is the prime number? I can't hear you. 2 factors only. What are the factors in 27? 1. Did you say 7? 1 and 27. Are you sure? Is that all? Are there any more factors? I can't hear you. How do we determine the factors of a number? For example, 27. So write out 1 times. What is the answer over here, Sheldon? What's the number here? 27. Can I write 2 times something? Cannot write. What about 3 times something? Can or cannot? What is the something here? Any more? Possible? 5 possible? All the way until 9 times 3 again, right? So what are the factors of 27? What are the factors? Sheldon? 1, 27, 3, 9. Okay, so these are the 4 factors of 27. So is 27 a prime or composite number? I can't hear you. Composite, yes. So it belongs here. Next number, 29. Prime or composite? Prime or composite? Prime. Okay, so these are the different numbers. Okay, now let's go on to part B. Find the next 5 prime numbers after 30. This is your homework. What is the sum of the next 2 composite numbers after 40? Also your homework. So find the next 2 composite numbers after 40, add them up. Then you get an answer for part C. Okay? Okay, then exercise number 7, you also can do it yourself. Any questions so far? Okay, then let us go on to prime factorization. Okay, so let us just look at the numbers 30 and 60. So we have seen that we can express 30 as something times something, right? So for example, 30 equals to 1 times 30 equals to 2 times 15, 3 times 10, then 15 times 2, and we see that this is a repeat, so we stop here. 30 is equal to all these, right? All these are known as factors of 30. Over here, factors and factors. But now, I introduce you something different. It is called prime factorization, which means in the factors are only 1 prime numbers. Is 1 a prime number? Nope. Is 2 a prime number? Yes, it is. Is 3 a prime number? Yes. What about 10? Prime number? No. It is not a prime number, so I don't want this number. What about 15? Prime number? No. 30? No. So I don't want all these numbers, okay? So how else can I represent 30? I can also write that 30 is equal to 2 times 3 times 5, isn't it? Check with your calculator. 2 times 3 times 5. Do you get 30? We do. In fact, you can take 2 times 3 is 6. 6 times 5 is 30. So, next thing is 2 a prime number? Is it a prime number? Yes. What about 3? What about 5? 5 is a prime number. Okay, so all these are prime numbers. So I express 30 as a product of all prime numbers. What about this 60 over here? I also can express it as all prime numbers. All of them multiply, I get 60. All these are prime numbers, okay? So if I'm able to express it this way, then this is called prime factorization. Now the question is, how do we get all these things? How do I know that 60 is equal to 2 times 2 times 3 times 5? There are many ways we can do it. We can either do repeated division, or we can use a factor tree. Okay? Let us look at the next page. If we do repeated division, have you seen this before? 2, 5, 2. Then I divide by 2. Have you seen this before? Then what do I get? 1, 2, 6. Right? Why did I put 2 over here? It is the smallest prime number that I can divide 2, 5, 2 by. So I divide by 2, I get 1, 2, 6. I continue. Okay, let me just take one more minute. One more minute, I'll wrap it up. 2, 5, 2 divided by 2, I get 1, 2, 6. What should I divide 1, 2, 6 by? 2 again. I always divide by the smallest prime number wherever possible. So I divide this by 2, I get 63. Now, can I divide by 2 again? And alright. Then what is the next smallest prime number? 3. What do I get? 21. Now, can I divide by 2 again? Can I divide by 3? Yes. And I get 7. Now again, I divide by the smallest prime number. Can I divide by 2? What about 3? What about 5? Then what's the smallest prime number? 7. And I'm left with 1, right? So now, I can write down that 2, 5, 2, in terms of prime factors, all these are prime numbers. 2, 5, 2 is equals to 2 times 2 times 3 times 3 times 7. Easy? Have you all learned this in primary school? No? Never, didn't learn. But easy or not? Just divide only, right? So this over here is your homework. Okay? So far, have you all learned something?